Hello, welcome to Maths Extension. Probably wouldn't have expected this, but we're starting off with chapter 14 of the textbook. Mostly because combinatorics is something we can study without having done stuff previously in Maths Advanced, and I'm hoping to teach the two courses completely separately, which is something they haven't done in previous years at St Paul's, so I'm sure it'll go well. No, it will go well. It's a logical way to do it. Combinatorics is a fancy way to say methods for counting stuff. Now, if you're just counting sheep in a paddock, you're like 1, 2, 3, 4. No, it's not that kind of counting. It's counting the number of ways we could have a group of 7 students all aiming for rank 1, 2, and 3 in the class. So you've got 7 options for rank 1, one of those is in rank 2, so you've got 6 options for rank, one of those is in rank 1, so you've got 6 options for rank 2, so one of those is in rank 1, one of those is in rank 2, so you've got 5 options left for rank 3, things like that. Now, in this textbook, we actually get into the methods for counting these selections later. First, we're going to learn about something called factorial notation. And factorial notation is these exclamation marks. So if you've... These exclamation marks here. That's not just maths being way too excited. It means that number times by all the numbers below it. So I wanted to start off with a meme. Let's go into the OneNote. Let's have a look at this meme. This kid's doing 3 times 4 on the whiteboard. He looks at a friend for help. His friend says 12. He's put an exclamation mark there because it's really obvious and he wants his friend to get it. But his friend's like writes 479,001,600. And that's because what is actually calculated is... Oh, hang on. Well, you can't see my face. I can't see my face when I'm with you. Okay. What is actually counted is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you were to bother writing all of that out in your calculator, 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals, quick maths, that. Luckily, we don't have to write that out in our calculators. Instead, we can literally go 12 and then there's a button for it right there. You've probably seen that button before. You've thought your calculator's just way over the top and excited. So we've got 12, and we call that 12 factorial. I'm so bad at this. We call that 12 factorial. Press equals. And boom, same number. It's actually a really simple concept. It's just any number multiplied by all the numbers below it. So for example, if we had, 3 factorial, then that's 3 times 2 times 1. If we had 2 factorial, that's 2 times 1. If we had 1 factorial, that's 1. Technically 0 factorial is 1 as well, but please don't get me there. 4 factorial is 4 times 3 times 2 times 1. You've probably noticed a pattern, and it's going to be very useful for what we do later. So 5 factorial is 5 times 4 times 3 times 2 times 1. But why do we bother writing all this out? Because we know this whole 4 times 3 times 2 times 1 is just 4 factorial. So why wouldn't we just write 5 times 4 factorial? That's going to prove really useful later. And that's what we call unrolling. So that's going to be the basis of the next video.